Hey everyone, greetings, salutations, all those nice things. Sorry I'm not there in person, but here is a lesson. In today's lesson, we're going to take all the stuff we did before with finding sine of an angle or cosine or tan, and we're going to use that to actually figure out what the angle is in a triangle. When we have something like this statement that says sine theta equals 5/8. We know that this up here must be the opposite. We know this down here must be the hypotenuse, and that's from the old SOHCAHTOA business. So it says if we draw a right triangle that has some angle in it, the opposite over hypotenuse is 5/8. So what is that particular angle? This is where we use the calculator. To get this sine over to the other side, we have to use what's known as its inverse function. And to get to that, we probably have to use the second function button or shift button on your scientific calculator. And I'm going to show you what that looks like in just a moment. But this is what we essentially need to write. So if we apply sine to this side, we'd get this ratio, but we're not getting the ratio. We have the ratio, so we're applying opposite of sine. So in the calculator, you would type out this exactly as it's written. To get that sine inverse, this part is where you'd have to use that second function button. So let's take a look at what this looks like. On my calculator, there it is. So I'm using this calculator. It's got a second function there. I've got my sine, cos, and tan buttons right here, and those are regular sine, cos, and tan. If I look just above them, I see there's this little sine with a -1 and this cos with a -1 and this tan with a -1. And that's what I have to use in this situation. So to access that for me, I have to press the second button and then the sine button. That gets me this blue version, right? Anything that's in kind of a bluish text on mine is accessed with this second button. So I press that. Second, where's sine? And I see this so far. And then I'm taking sine inverse of, it was 5/8. So I'm just typing that in as division, just 5 divided by 8. I can close the bracket. And when I hit equals, or enter on my calculator, I get 38.6821. So I'm going to put that as the answer hereabouts. There we go. Oh, no, wait. We had this one. It's right there. So make sure in your calculator you can get the exact same value. Super necessary to have us getting the same value out of our calculators. It might be possible that your calculator's in a different mode. So for that, you can always check, like you might be getting an answer like this instead. That's not 30-something degrees. That's 0.67513. If you're getting an answer like that, that means your calculator is in a mode called radians mode. It'll say rad or might have an R on it. And you want to make sure it's in degrees mode. On my calculator, I have to press this DRG button. You might have a mode button or something that indicates that you need to switch between D's or R's and G's. So for me, I have to press this DRG button. It pops this up, and I need to scroll over to deg for degree, and then hit enter. And now when I type this in, I'm getting the right answer after all. So that's how you can have that workaround. Do be familiar with your own calculator so that you don't accidentally have that issue on a test. I mean, like I can help you out if it happens, but it's going to take up time. So again, this is how we have to write that. We say theta is sine inverse of 5/8. That's how we move this sine thing to the other side while keeping theta itself locked in over there. That notation is very particular. We can't write something like like this. So that would be a bad notation. It does, like if you're gonna write what you're doing to move sine over to to the other side, then you could write it like this. I don't recommend doing so. I recommend just having the initial up here and then what it turns into. Sine's on the other side, but it's opposite sign because it's on the other side. So let's solve for these. So for this, just like the example above, we're going to get theta on its own by moving this cosine to the other side. But by moving it to the other side, it turns into inverse cosine, the cosine with a -1. And we're taking that of this number we were given. Your calculator will give you an answer for that. Type yours into your calculator. Make sure you can get whatever I get here, assuming I'm correct. How many? I mean, 1 decimal place. So this is 49.7 and then degrees. We've got that degrees sign up there because that's how we're measuring this angle. Excuse me. All right. There's a couple more examples on this page. Oh, one more example. Oh, wait. I found them. 3 more examples on this page. Okay. Please try the next 2. Try examples B and C. If you want, you can try example D as well. Something weird's going to happen when you try example D. And we'll talk about why that happens in a moment. But first, take like 3 minutes and try examples B and C. See what you get. Pause this video and then resume after those 3 minutes have elapsed. Alrighty, in the hopes that you pause the video, try the examples. Here's what we should get for these next ones. In example B, we get theta on its own by moving the tan to the other side, but when we do that, it becomes opposite tan. The number still stays the same, 0.988. And to 1 decimal place, according to my calculator, that's 5.6 degrees. Next one. Oh, wait. Whoop. Missing something. I totally did that on purpose. I didn't do that on purpose. Sometimes mistakes happen. It's probably a good thing. It gives us something to watch out for. But I missed the little degrees sign here. So that does have to be in there. Next example. We get theta on its own by moving sine to the other side. When we do that, it becomes opposite sine. And that's of 0.8420. And if you punched in your calculator correctly, you might have gotten 57.4 degrees. Oh, shoot. I should have probably mentioned, if you aren't able to see the display on your calculator, you might have to press the buttons in a different order. So when I type in sine inverse of 0.8420, I see all that, right? I see what I typed and I see what the answer is. And having a calculator that shows you both what you typed and what the answer is very handy. You can type things in exactly directly as we see them. And I very, very strongly recommend that you have a calculator that lets you do that. If you don't, you might have had to hit the buttons in the opposite order. So instead of hitting, second sine of whatever the number was, you might have to type in, that 0.8, whatever it was first, and then hit second sine. I'm not going to do it on this calculator because this calculator is going to say that's wrong. That's not how we write things. But if your calculator does not show you the display, then you are going to have to make that change. All right, moving on. Example D. There it is. That next step says we take cos and move it to the other side, but that's opposite cos now. And we go 2.5651 in the brackets. I'm going to type that into my calculator. You'll hear it with me pressing the buttons. 2.5651. On my calculator, I got domain error. I guess I was a little too enthusiastic about that one. Yeah, you might have gotten some sort of error. And if you have a domain error, there's actually no solution here. And the reason is because we said that adjacent divided by hypotenuse was 2.5651. So like the adjacent side was 2.5 times the size. Adjacent side. It's 2.5 times as large as the hypotenuse. And that's a huge no-no, because that makes the adjacent side longer than the hypotenuse. And one thing that we know for sure is that the hypotenuse is the longest side in a right triangle. So that's why that happens. You probably won't encounter that very often, but it does happen. So watch out and know how to handle it. All right, we've got a triangle. And in this triangle, we're solving for theta. When we are doing so, it might be handy to first label the sides, the opposite, the adjacent, the hypotenuse. So if I'm playing with this one, I'm going to label this 9 side. You're right. You label it. See what you can do. Try labeling the sides as opposite, adjacent, hypotenuse. I'll give you a good chance to have some water. Anyhow, the 9 is the opposite side. 16, that's across from this right angle, so that's our hypotenuse. And then the other remaining side, the one that's next to theta, but is not the hypotenuse, that is, of course, our adjacent side. And when we look at this, we note we're working with the opposite and the hypotenuse. So, if we're thinking of good old SOHCAHTOA, that means we're working with the SO part of things. So that's the sine ratio. So we can write that down. We know that sine of theta is opposite over hypotenuse. And for that statement, we know some stuff, right? There are some known values here. We don't know what theta is. That's unknown. But we know what the opposite is, and we know what the hypotenuse is. So we fill those in. Now, once we have this is just like the scenarios on the previous pages. We have to get theta on its own. We have to move sine over to the other side by taking opposite sine. So we'll say theta is opposite sine of 9 over 16. And we put that into our calculator. Yeah, I don't know what I get. Second sine, oops. Saw that domain error up. Second sine of 9 divided by 16 yields 34.2 degrees-ish. And that is that. And again, making sure we put that degree symbol there. Don't omit that. Take a moment. Try examples A, B, and C here. See what you get. So pause this video for a solid, 7 minutes. And then resume it to see if your answers match up with what is in here. But please do actually try it on your own first. You'll want to make sure you can do that. And if there's any parts where you struggle, like your answer is different from mine for some reason, and you can see why that error happened, make sure you add that to your resource sheet, because it'll be handy to have to keep in mind for quizzes and tests, and even for your practice work. All right, I'm assuming you've paused for 7 minutes and restarted after having tried the examples. So, starting here for my angle, 39 is opposite, 40 is adjacent. There's also hypotenuse, but it's not super relevant. I'm going with the tan ratio because that deals with opposite and adjacent. So for this triangle, tan theta is 39/40. And isolating theta means we take opposite tan of 39/40. And according to calculator, what are we doing? 1 decimal place. According to calculator, this is 44 point, nope, not 0.2. Digit after is a 7. 44.3 degrees. Next example. 84 is opposite. 87 is hypotenuse. And then this other side's adjacent, which we don't need in this case. But we can set things up using the sine ratio. Sine of theta is opposite over hypotenuse. So sine theta is 84/87. Oops. So theta is opposite sine of 84/87. And you've already punched this into your calculator. But in mine, this says 74.9 degrees. Last example, we've got theta. This 29.4 is adjacent. This 34.3 is hypotenuse. Remaining side is opposite. So I'm using cosine. So that's adjacent over hypotenuse. Adjacent is 29.4, hypotenuse 34.3. So we take opposite cosine of 29.4 divided by 34.3. And what does that give me? Oops, 29.4 divided by 34.3 equals... Ooh, I got 31.002719 and some other stuff. When I'm rounding, I can't just put this. If I need to show that there's the nearest tenth, I need to actually show that tenths place, even though it's a 0. So that's that. And that's it. That's how to find angles in triangles using trigonometry. So there is some practice work on the next page. Give it a go. Give it a whirl. Make sure you're super comfortable with it. And again, as you're working through, be aware of where you have any struggles or any difficulty whatsoever. Even if you get that addressed and answered and you're like, yes, I feel good with it now, still note it down somewhere, probably on your resource sheet, so that you have a record as to how you overcame that struggle or that difficulty. That is, well, it has been most lovely. Tell everyone I say hello. Be good to yourselves, be good to one another, and don't forget to do the math. I will see you in the future.